this video, we are going to talk about some of the random topics that we have left in this chapter, which are very, very important. Like some of the reactions are there, some electronic dot structures are there, like of hydronium ion, ammonium ion, then the use of pH scale, where you are using these pH scales and all. So acid rain and all. So all these things we will discuss in this video. So let's start with the reactions, important reactions in this chapter. The first reaction that is in your chapter is production of acid using non-metals. How we are going to produce it? H2, make it react with any of the non-metals like chlorine, iodine, then you will get an acid. Now what is the way to remember these reactions is to remember the key statement. The key statement says that if hydrogen is made to react with any of the non-metal, it will give an acid. This you have to remember. Rest depends on the example that you have taken. Okay, let us take another example. Suppose I'm taking hydrogen with another non-metal like iodine. So it will give me another acid, hydrogen iodide, and after balancing, it's 2 molecules of hydrogen iodide. So this was the first reaction that you have to remember. Second is getting bases with the help of metal. Means when a metal is made to react with oxygen, it gives bases. Means species which will have basic property. Let us take example for it. Suppose I am taking Na, making to react with oxygen. What I will get is Na2O. How? By valency exchange method. Oxygen has 2 negative charge, sodium plus 1. They will interchange. They will give you Na2O. Now let us balance it. 2 Na are here, so 2 Na. Now it is not balanced. Still it is not balanced. Oxygen is 2. So let us make it 2 again. Now, while balancing oxygen got balanced, but now sodium got unbalanced. So let us make it 4. Now this is the balance reaction. 4 Na reacts with a molecule of oxygen to give you 2 molecules of sodium oxide. Now a question will arise in your mind that why we are calling it a base, or why it will show property of bases. See, this is a basic oxide. It means this oxide will exhibit the property of bases. That is why we are getting base here. Sodium oxide is a base. Now how to remember? There are two things in your chapter: basic oxide and acidic oxides. Oxides are of 2 types given there. So let us discuss them first. See, I'm going to write it here. How to get a acidic oxide and how to get a basic oxide, that we are going to discuss. So again, the key statement is metal when it reacts with oxygen gives you a basic oxide. Second point, non-metal whenever reacts with oxygen gives you acidic oxide. In the previous video also I told you that what is the meaning of acidic nature, what is the meaning of basic nature. It means if I get this acidic oxide, it will exhibit the property of acids, like it will have a pH less than 7. Okay, and if you are using indicators, it will turn blue litmus to red. These are the properties of acid. So if it is acidic oxide, it will show all the characteristics of acids. Okay, so key statement is metal with oxygen, basic oxide; non-metal with oxygen, acidic oxide. Now again, take some examples. Let us take metal potassium, make it to react with oxygen. What you will get? You will get K2O. Another example, suppose magnesium with oxygen, you will get MgO. Let us balance it. Twice K plus O2 is giving you K2O. But again, oxygen is not balanced. So 2 here. Now again, potassium got unbalanced. Write 4 here. In this way you are going to balance it. Remember that balancing method, there is no particular method for balancing. That is called hit and trial method. So I hit a number 2 here earlier to make potassium balanced, but again the trial gone wrong, because when I balanced oxygen, then this trial became wrong. Earlier it was correct, but while balancing oxygen, the trial became wrong. So again I hit a number 4. Now this is Correct. That's why it is called hit and trial method. Now for magnesium, Mg is balanced, but oxygen is not balanced. So let us make it balanced by adding 2 here. Now when I added number 2 here, it made magnesium twice, and here magnesium is single. Let us make it 2. Now it is balanced. So metallic oxide, again a metallic oxide. So remember that metal when reacts with oxygen gives you a species which is basic in nature, means basic oxide. And what are acidic oxides? Let us take example. Suppose I am making any non-metal like sulfur to react with oxygen. So what it will give? It will give SO2. So definitely SO2 is a acidic oxide. Another example, let us take of carbon, make it react with oxygen, CO2. Again it is a basic oxide. Okay, sorry, acidic oxide. So for basic oxide you need a metal, for acidic oxide you need a non-metal. Whatever species you will get, it will exhibit the property of base or acid. It depends whether you have taken a metal or a non-metal. If it's a metal, then basic oxide. If it's a non-metal, then it's acidic oxide. So I hope acidic and basic oxides are clear to you. Now why I called Na2O a base, means showing property of base. I hope it is also clear to you, because this is a metal, I made to react with oxygen and I got Na2. So since it was a metal added to oxygen, it means this is a basic oxide, metal basic, and with acid, so with the non-metal you are going to get acidic oxide. So remember that what are acidic oxide, what are basic. I hope you can give the theoretical definition. What is the theoretical definition? Oxide obtained when a metal is made to react with oxygen is called as basic oxide. Now what is the theoretical definition of acidic oxide? When a non-metal is made to react with oxygen, or simply when a non-metal reacts with oxygen, the resulting species that we get is called as acidic oxide. In this way you can answer it in theoretical way, and for the reaction you can use these reactions. Whenever you are watching these type of reactions, pause the video and make a note of it in your note copy. Okay, now let us move on to the next reaction which is important in your chapter. It's a reaction of a metal with acid. Now this is a standard reaction. What do you mean by standard reaction? A standard reaction is a reaction which will always give the same product. So whenever metal reacts with any acid, it will give you a species with a liberation of hydrogen gas. Remember, it is a test for metals. Suppose any element X is given to you. I don't know whether it is metal or non-metal, or metal or something else. So if you make X to react with acid and it liberates hydrogen, then definitely X is a metal. If hydrogen liberation is not there, then definitely it's not a metal, it will be some other species. So this is a standard reaction for the test of metals. Metals when react with acid gives you, liberates hydrogen gas. For example, in the class 9 chapter, hydrogen chapter, you have studied lab preparation of hydrogen. So in that also we are making zinc to react with HCl. Now see, same condition, metal, acid. So what it liberates? It liberates hydrogen with production of ZnCl2. So that reaction was also a standard reaction which shows that metal when react with acid liberates hydrogen. So this was another reaction that was in your syllabus. Okay, next reaction is neutralization reaction, which is a very old reaction that you are learning from the previous classes. From the 7th it started. So what is neutralization reaction? The word neutralization itself means that you are neutralizing something. It means reactants are being neutralized. How they are being neutralized? See, let us take a simple reaction. Acid, make it to react with any of the base. It will give you NaCl plus H2O. You should know why we are calling it neutralization reaction. See, HCl is an acid. It's an acid. Sodium hydroxide is a base. Now see in the resultant side what you are getting. Are you getting any of the base, or are you getting any of the acid? No, nothing is there. Neither acidic nor basic. So it means that the overall effect of the reactant has been neutralized. Now there is no acid content in the resultants and neither there is any basic content. It won't show, this NaCl won't show acidic or basic character, this water won't show any acidic or basic character. Okay, so since the effect of reactant has been neutralized, the property of reactant has been neutralized, so this is called as neutralization reaction. Again, the key statement is acid reacts with base to give salt plus water. This you have to remember. Acid when reacts with base gives salt plus water. Now it depends what example you are taking. For example, I have taken this example. Instead of acid I have taken HCl, instead of base I have taken sodium hydroxide. So what I am getting? Salt, chloride. Chloride part is a salt. I told you in the previous video also that chloride, iodide, sulfate, phosphate, nitrate, all these are the examples of salt. Okay, so salt plus water. This is the key reaction that you have to remember, the main part that you have to remember. Rest depends on the example that you have taken. So these were some of the reactions. Now another reaction is, already I told you about acidic and basic oxide. Acidic and basic oxide. So whenever acidic oxide reacts with water, now we are not going to memorize this reaction. Okay, let us do that reaction first, then you will get the answer. No need to memorize it. So let us take example of any acidic oxide. Suppose CO2. It is an acidic oxide. Why? Non-metal with oxygen. Make it to react with H2O. Combine it. What you will get? You will get H2CO3, carbonic acid. So now you can make this statement full. What will be the word in the RHS side? What will be that word? That word will be acids. That is why I told you, no need to memorize the reaction. Just take the example, then you will get what should come in the product side. Okay, let's take another example. Make SO2 to react with H2O. Again, the standard part says that you will get an acid. So which type of acid, which acid has chances to form here? It's H2SO3. Sulfurous acid, not sulfuric acid. Sorry, sulfuric acid. Not sulfuric acid, it's sulfurous acid. Why? Lower valency, so you have to add OUS. Okay. Suppose I'm taking SO3, H2O, then it's H2SO4, sulfurous acid. Okay, sulfuric acid. So this is your sulfuric acid. If oxygen value is 1 less than the standard, I know that this is familiar term for you. Sulfuric acid is a familiar term for you. So whenever an oxygen is less, one oxygen is less, add OUS. For example, HNO2, HNO3. Now you know HNO3 means nitric acid. Again, one oxygen less, add OUS, so it will become nitrous acid. I hope it is clear. H2SO4, sulfuric acid, O3, sulfurous. HNO3, nitric acid, HNO2, one oxygen less, nitrous acid. In this way you can remember it. Okay, so in this way, whenever you are making an acidic oxide to react with water, you are getting, sorry for the interruption, some technical faults were there. Okay, so we were on this part, sulfurous acid and sulfuric acid. Okay, in the same way you can take nitrous oxide or nitrogen dioxide to make it to react with H2O, then it will give you nitric acid or nitrous acid. So in this way you can make different acids, but the standard reaction is acidic oxide with water gives acid. Now what about basic oxide? Basic oxide with water. Again, we won't write the resultant part. First we will do the reaction. Let us take a basic oxide, suppose Na2O. Make it to react with H2O. Now see what are the chances of formation? Twice Na, 2 oxygen, 2 hydrogen. Combine it, what you will get? See, 2 Na, 2 oxygen, 2 hydrogen. In this way you can remember it. Okay, so see this part. NaOH. Very simple. NaOH. And two are there. It means the overall product is twice NaOH. So what we have to write in the right hand side? We are getting metal hydroxide. In this way, you should remember reactions in chemistry. Do not memorize those reactions. If you can memorize, it is good. But if you are not able to memorize, write the product, then you can write what is the resultant part or what is the product side part. Okay. So take any of the basic oxide, make it to react with water. It will give you metal hydroxide in the case of basic oxide. But in the case of acetic oxide, if you make it to react with water, it will give you acids. So this was the reaction, important reaction part that we had to discuss. Now, next part is use of pH scale. What are the uses of pH scale? See, pH scale, first of all, has its application in agriculture. Suppose you want to cultivate any type of crop, like you want to cultivate citrus fruits. And your soil is acidic in nature. So you tried many times for some citrus fruit like lemons and all. You tried your best, but you're not getting the product. Then what do? We take that soil for testing. In the test, pH scale is used, or we are taking out the pH. If it is possible for the scale to measure, it's okay. Otherwise, we take the hydrogen ion concentration, and in that way, as I told you, pH equal to minus logarithm of H plus ion, or concentration of H plus ion. In that way, we can take out the pH. Now, what the reports told you, the report told you that your soil is acidic in nature. So it means that this was the reason why you were not getting your required crops or required whatever you wanted to produce. You are not getting that. Why? Because your soil was acidic in nature and you were trying to cultivate some citrus fruit. So citrus fruit need alkaline medium or alkaline soil, but your soil was acidic in nature. So pH tells you whether a particular crop is fit for your soil or not. In the same way, for rice, for sugarcane, for all these things, you have a different types of soil. That is the reason why in cold areas you can cultivate apples, but it is not possible to cultivate it in warm areas. For that, even if you're cultivating in warm places, then you need to do some extra efforts. But naturally, if you want to grow, suppose apples, so for that you need a cold climate, and soil will be also like that only. For tea, different soil, red soil we need for tea. So why it is happening like that? Because particular crop need particular type of soil. So for that we can use pH of soil. In that way we can cultivate. For sugarcane, we need neutral medium or neutral soil, neither acidic nor basic. So in this way we use pH scale for agriculture. Next is biochemical reactions happening in your body also depends on pH scale. If pH is higher, a particular type of reaction won't take place. If pH is low, some of the reaction won't take place. So in your body also many of the reactions are there which are taking place at a particular pH. Okay, that's why whenever your acid content in your body increases, your body does not function well. Why? Because the pH of your body has been increased. Okay, then you take medicines from outside to maintain that pH level. So biochemical reaction in our body are also dependent on the pH value of our body. Okay, so in this way you can use pH for different things. Even for checking milk you are using pH. Even for checking milk, suppose the content of acid rises, then it gives you a foul smell or a sour smell, or it will give a sour taste. It will give a sour taste. So how you get to know? You can check it by pH. We are dipping that pH paper, or we are checking the pH value of the milk. Then according to the pH value, we are using that milk. If pH is high, it means it is not fit for drinking. So in that way, we can test milk also. Purity of milk can also be tested by pH scale. So these are some of the points that you can write in your examination regarding use of pH scale. Okay, let us move on to the next topic. The next topic is your electronic dot structures. How to draw electronic dot structures? Two examples are there. One is of hydronium ion H3O positive. One is your ammonium ion. Very easy. See, this is a combination of H2O plus H plus, and this is a combination of NH3 plus H plus. In this way you can remember. It does not matter from where you are getting that proton, but the key factor is ammonia when grabs a proton and water when grabs a proton, then you get hydronium ion or you get a ammonium ion. Okay, and H2O and H3 both are polar covalent structures. So if you draw the structure of H2O, what will be the structure? This is O. How many electrons are there? 1, 2, 3, 4, 5 and 6. 2 hydrogens are there. Here first hydrogen. So with dot I am showing its electron. Dot H. Now for hydrogen it's duplet. For oxygen it's octet. So duplet and duplet. For oxygen, this is the diagram. So oxygen has completed its octet, hydrogen has completed its duplet. And remember that 2 electron means 1 bond. Implies now these 2 electrons converted to bond in this way. Oxygen again a bond, hydrogen, 2 electrons are here, this one and this one. Now these 2 electrons are unused. These are unused electrons and they are called as lone pair of electron. Now what is the definition of lone pair of electron? Pair of electrons that do not take part in bonding. See, here also in the structure you have seen that these 2 electrons are separate. They are not taking part in bonding. This electron of oxygen is taking part in bonding and this electron is taking part in bonding. So they are bonded here. We have made a bond. But these 2 electrons were not taking part in the bond formation. So they are called as lone pair of electrons. So the definition says that pair of electrons which do not participate in bonding are called as lone pair of electrons. So we can say that oxygen has 2 lone pair of electrons. Now what it will do? Suppose now a proton comes to make bonding with water. Now proton means hydrogen means 1 electron. Proton means that also donated. Okay. So it does not have any electron. And without electron bonding is not possible. For bonding you need electrons. So what it will do? It has 2 lone pair of electrons. So one of the pair will be used for bonding. Now see, only this part took initiative, or we can say only this part used its electron for bonding. This didn't had any electron, so how can it participate? It didn't participate. So overall structure is H2O dash H. What does this mean? This means this arrow means electron were used from this part, not from here. The bonding electron has been used by water, has been provided by water, not by this H, this proton, because it didn't had any electron. In the same way you can draw the structure for ammonium ion. How? See, same structure, NH3, 1 lone pair of electron, proton will come, then donated, then NH3 arrow in this way. Why? Because ammonia provided that pair of electron for bonding. H positive charge, ammonium ion. Very simple to make it. You can make it very in a simple way. You can make it. Okay. So first in the examination you have to draw the structure of H2O, just as here, and also you can draw for ammonia in the same way. Nitrogen, hydrogen, hydrogen, and hydrogen. In the same way you can draw for ammonia also. Then make it to react with a proton. Proton does not have any electron. So here electrons will be provided by water, mean lone pair of electrons will be provided, and here 1 lone pair by ammonia will be provided, and this is the overall structure for formation of ammonium ion, and this is for hydronium ion. Actually what is hydronium ion? It is a mixture of water with a proton. Okay. So this was your electronic dot structure. So for the last part we will make a separate video because the video will become lengthy. Okay, so what we discussed today is we discussed some of the reactions, important reactions. Then we discussed about acidic oxide, then your basic oxide, reaction of acidic and basic oxide with water, what does it gives, then standard reaction, of metal with acid. Then we discussed about neutralization reaction. Then we discussed about pH scale. At last we discussed about dot structure of hydronium ion and your ammonium ion. NH3 plus, NH3 plus H plus, ammonium ion, H2O plus H plus, hydronium ion. So these all topics we discussed in this video, and in the next video we will discuss acid rain in brief. It won't be a lengthy video. What is acid rain? Definition. What type of acids are present there? How these acids are being formed, and what is the side effect of acid rain? Okay, so all these topics we'll discuss in the next video. Today, focus on these topics that we have discussed today. Okay, so I hope all these things are clear to you. So keep going, keep studying, and do well for your examination. Thank you.